Good afternoon to dear student. I am Monika Kherajani, Assistant Professor, SIT College, Bhopal. So today's topic is the memory management and subject operating system. So let's begin with this lecture. And today's contains memory management and different types of memory allocation techniques. Now, before what is the memory management? Memory management, as we know, it is a vital function of the operating system, which is responsible for managing the primary memory. It also facilitates the movement of the processes between the main memory and the storage disk and enabling the seamless operation. Memory management allow the operating system to maintain the comprehensive record of the all memory location, regardless of whether they are assigned to the process or remain allocated. As we already discussed in the process management, like there are the different processes and how these processes get the CPU. Similar way, before executing any process, all processes are required the memory and how the memory will be allocated these processes. So in this unit, we will discuss the all techniques for managing the memory. The main primary goal of the memory management is to system overall performance by ensuring the efficient utilization of the memory resources. Now, as we know that for managing the memory, there are three important criteria are always considered for managing the memory. The first criteria is for any memory management technique, the size of memory should be large enough so that we can store the maximum amount of the data in the main memory. And accessing time should be always minimum. Like whenever I want to access any data and program which are stored or reside in the memory, so I can easily access that data without wasting my time. And the unit cost of every memory should be less. Now, all these criteria are always important for the managing the memory. Now, question arises: is it possible all these criteria in a single memory? No. All these criteria are not possible in the single memory. So we have the hierarchy of memory in order to attempt all these criteria in the same way. Okay. So now a question arises: how does hierarchy of memory works to attempt all these criteria? Like as you see uh, in the hierarchy, there is a secondary storage. Okay. For this secondary storage, we can achieve the or increase the size of memory. And as you see in front of the secondary memory, there is a main memory, and again in the front of the cache memory, and again in the front of the registers, and then there is a CPU. So these are the hierarchy which are work on the locality of preferences. Okay, and this register is considered as the fastest memory than as compared to the fastest memory. Then cache memory is the slowest memory again in the main memory, which is again slowest to the cache memory. And secondary storage is the very less storage memory. It is storing the so much data, but access time which are used in the secondary memory is very much high. So for that, all these memory are placed in such a way so that we can reduce the accessing time. But as you can see in this diagram, we will only concentrate on the main memory because all the programs which are going to be executed, it should be always placed in the main memory. Okay. So by default, all the programs will be stored in the secondary memory, but we run or execute the program, then these programs should be moved from the hard disk to the main memory. Okay. So in this way, we will achieve the all three criteria which we have discussed in the previous slide. Huh. So these are the background for managing the any memory. The program must be always we manage the uh, when we manage the memory, the all program must be brought from the disk into the main memory and placed within the process for it to be run. Then main memory and register are only storage CPU can access directly. Memory unit only see the streams of the addresses, read request, address plus data and write request. Register access in a one clock should be less. Main memory can take many cycles. Cache memory should be always set between the main memory and CPU register. And the protection of memory required to ensure the correct operation. So these all are the criteria or consider for when we manage the memory. And these are the mainly whenever any process is moved from hard disk to main memory, all these should be kept in the mind. All these should be performed in managing the memory. Now, when we manage the memory, the two problem always arise. So these two problem must be solved for managing the memory. The first is how we can allocate the memory. What are the different allocation techniques? And second problem is address binding or address translation. Okay, so we will discuss one by one. First, in this lecture, we will only discuss about the memory allocation techniques. As you see in the diagram, the memory management techniques are classified into two categories: contiguous memory management and non-contiguous memory. As the name implies, contiguous means whenever any program is to be going to be execute, then it requires the memory, then whole program will be stored or allocate the memory in the contiguous form. And contiguous memory again are divided into two categories: single contiguous memory management and multiple contiguous memory. As single partition means there is only single partition for managing the memory and is allocated to the any process, and multiple partition means there are a multiple partition and each process will get the different partition to execute their program. The multiple partition are again divided into the two categories: fixed partition and the dynamic partition. And there is another classification of memory, that is a non-contiguous. Non-contiguous is again divided into the paging and segment. So in this lecture, we will only focus on the contiguous memory techniques. Okay. The contiguous, as the name implies, contiguous means when the process arrives from the ready to the main memory for the execution, the contiguous memory blocks are allocated to the process according to the requirement. I have already discussed. We will basically allocate the contiguous, means whole block of the memory is allocated to the any process. I mean, there should be contiguous memory will be available for allocating the process. Okay. Now, to allocate the contiguous space to user process, the memory can be divided either in the fixed size partition or the variable size partition. The contiguous block of the memory is allocated to the process. Okay. The contiguous is again divided into the two categories: fixed partition scheme and variable partition scheme. As you see in the fixed partition allocation techniques, in the fixed alloc in a fixed partition, as you see in the diagram, the memory is divided into the divided into the fixed number of the partition. Like there is a one block of 50 KB, then 100 KB, 250 KB, 150 KB, 70 to 20 KB, and 3. The fixed number means the number of partitions are fixed in the memory. All memory is divided into the fixed size partition. Okay. In a fixed size, number of partition are fixed in the memory. In a fixed size partition, in every partition, only one process will be accumulated. As the name implies, fixed size means Whenever any process need the memory, so we will allocate the only one process in this partition. Okay. Suppose there is a 50 KB partition is available, but any process require the 30 KB, then we will allocate this partition. The remaining 20 KB will be wasted. So this problem is known as the internal fragmentation. Okay, the degree of multiprogramming restricted by the number of partition in the memory, and maximum size of process is restricted by the maximum size of partition. Every partition is associated with the limit registers. Okay. In the variable partition, there is in this variable partition, the memory will be a contiguous free block. Means we are not need to divide the memory in the fixed partition. That is a variable partition. Whenever any process is coming, according their requirement, we will divide the memories. Okay. Whenever the request by process arrive, according the partition will be made in the memory. If the smaller process keep on coming, then the larger partition will be made into the smaller partition. In a variable partition, initially the memory will be the full contiguous free block and memory divided into the partition according to the process size. Whenever any process size will be vary. One partition is allocated to the active partition. Like if one process is coming 50 KB, then we will allocate the 50 KB. Then next process is coming and he is acquiring the 100 KB, then we will allocate the 100 KB. Then there is a no problem of the internal fragmentation. In the fixed partition, there is a problem of the internal fragmentation where the memory space is wasted if any process is coming of the same size, but we cannot able to allocate that free space to the upcoming process. In a now question arise how we will satisfy or allocate the empty or allocations or the fixed free blocks to the processes. There are the three techniques are used: first fit, best fit, and the worst fit. Allocate in a first fit, we will allocate the first hole that is a big enough. Best fit means we will allocate the smallest hole, means the smallest partition that is big enough and must search the entire list unless ordered by the list. Worst list as worst fit means allocate the largest hole and must also search the entire list and produce the largest leftover hole. So these all fixed partition and variable partitions can be achieved by allocating these technique: first fit, best fit, and worst fit. First fit means we will search from the entire list of memory, and whenever we will get the first empty block, then we will allocate that process to the memory. Then best fit means we will search the entire space and we will find the free partition in which we can easily accommodate that process. Worst fit, if there are the smaller block is also available to accommodate that process, but in a worst fit we will search the largest empty block. Okay, as we discussed earlier in the fixed partition, we will face the internal fragmentation. Internal fragmentation problem is to allocate the memory may be slightly larger than the requested memory, and this size difference is a memory internal to the partition but not being used. An external partition fragmentation problem we will achieve in the variable partition. External fragmentation problem is that if any process is coming of the 50 KB and we have the available size is 50 KB in the different partition like 30 and 20 KB, but they are not in contiguous, so we are not able to allocate the 50 KB space to the process because all the free blocks are available in a scattered form. So this problem is the external fragmentation. So we can reduce external fragmentation by the compaction technique. Then compaction means what? We will shuffle the all memory contains to the place all free memory together in a one large block compaction is only possible if the relocation is dynamic and it is also done at the execution time. Okay. But this technique is very much complicated because we need to change the addresses of each process and then combine the all empty block at the one end. So these techniques can be overcome and reduced by the non-contiguous memory allocation, which we will going and discuss in the next lecture. Thank you. Thank you so much and have a nice day.